Good morning. And it's a great honor to be here. I really enjoy this event. So AI for Good really bring us a lot of things. And also it's a good opportunity for people to get to know each other. And so today I really want to share some of the work that we did at the Zhejiang Lab, and particularly about relationship between computing and AI, and how we can use this latest technology to explore the area they probably never could touch it before. And if you're just looking at the, if you look at how we have this topic about the computing AI, so for me, computing AI is more like two sides of a coin, okay? And if you go back about 2 years before, actually, Alan Turing had his first paper talking about the relationship between computing and intelligence. He actually wrote a report at the late 40s, and talking about what human looks like, if you're thinking about it's a universal machine. So this is a very famous quote, okay? And so basically, it tells us, and the paper on a person with pen and paper is a very powerful machine. So for me, today, that even though we have the computer, it's pretty much like plays a role, like a pen and paper. So I always think, pen and paper is a great tool, and at that time, it works like a computer. And the next year, and Turing published this first paper about the computing and intelligence, okay? So again, I want to emphasize Turing first talking about the intelligent machine, okay? Then talking about the relationship between the computing and the intelligence. So I'm glad actually the paper was published in the psychology journal. Just let you know, I have a psychology background, okay? And what's more interesting is, when he started thinking about this, actually, the word computer is not really a machine. It's actually, it is a person do the calculation, okay? So at that time, even without computer, Turing envisioned whether we could eventually could have some, he called a digital computer, is basically a person and a device that could do, people could do at that time. And again, if forgot about the computer and back to the very basic of what we call computing, I think it's a phenomenal thinking how important for us, okay? So there are two ways you can think how important for us. The first is computing is really the way, it's not just a tool, but it's really the way for us to thinking and solve the problem, okay? And the second is computing is not just a sub-area for the computer science department, okay? It is an area that in parallel with the physics, with the life science, okay? So it is very, very fundamental. And that's why today the AI could build on top of that. And last year, when the AI pioneer win the Nobel Prize, and a lot of things have been changed, okay? And the first thing I'm really happy to see, I think it's very fit the theme of this event, AI for Good. And when the Atlantic magazine and reported, it says it's AI's penicillin X-ray moment. And it really tells people AI is doing good for the humankind, okay? And that actually really encouraged, because at that time they very work hard on how AI could transform the way people doing the research, and certainly science technology has people as well, okay? And more interesting is when the Fortune magazine introduced Jeff Hinton. He actually did the presentation yesterday. The magazine actually first introduced Jeff Hinton as a cognitive psychologist, and then a computer scientist, and then as the godfather of AI. But Jeff Hinton wasn't a psychologist before. He really worked on the work he does over here. And if it goes back like in the middle of the 80s, and Hinton actually published a lot of paper together with the psychology at that time, okay. So basically, you can understand psychology is really an area, really care about the people. So thinking about this, all the early pioneer, they really thinking about, okay, what's the relationship between the AI and the human beings? And in that sense, okay, so for me, the AI has nothing to do with the human intelligence. So I really think, it is a technology, help to extend our creativity. So it is a tool, but it's a much better tool than the pen and paper. And so with all the technology, the human could do something that they may not able to do without these incredible tools. And certainly, so my passion and the lab actually is very much focused on how the technology could help the scientists. But certainly, we need to understand what science needs for that, okay. And this actually is in a paper published almost 10 years ago, and by a geologist, okay. So what they need is very simple. They want to be able to share all the research data. That's the data about rocks, okay. And secondly, make sure they could share all the research results. And the third, that they have the infrastructure. They could do the work together, okay. So it's a very simple requirement. It just turned out to be something that AI could help that, okay. And that's why, 3 years ago, that inspired the vision of deep time digital Earth. That was the first proposed by the IUGS, and we really inspired the vision of the DDE. Then we started what we call the GeoGPT project. But basically, it's an AI system to help the geoscientists, and just like what you see from that paper 10 years ago. And I'm sorry. And even though it's just a tool that actually looks like, just to get the feedback from all scientists. And it turned out to be very helpful for the scientists around the world, okay. So I'm very glad, actually, when we attend to different conference, like in April, we were in EGU, and also we went to different conference. And if you look at the people, they use that, actually from all the different countries, okay. So again, I would say, it is a requirement from the scientists, but also it helps the scientists, okay. And also, I'm glad, actually, we work with Michael Stevenson, and he really worked on very close with us, okay. So we're doing what we call the classification of fossil spawns, okay. It is a very interesting paleontological classification, and with this simple technology, and certainly powered by AI, then we can find the number of different types from to the 2-digit to over the 3,000 of them. So it is just an eye-opening discovery, how could help the scientists. Probably without this kind of technology, you may not able to having this kind of discovery for the rest of your life, okay. But I'm really glad is Mike actually took this center to Africa. So he had a seminar in Nigeria, and it really helped the scientists over there doing that research, okay. And I'm really glad you can see his quote over here. And the other progress for this work, even though it's very much focused on the geoscience, but actually with this work, we define an open AI architecture for scientific discovery. The first thing to make sure that actually everybody knows that actually today there are different large language model, and we call it foundation model. And we don't make sure that the user have the choice for different open source models they want to use. Okay, so the first selection, first decision for the GeoGPT will make sure it works on different open source models. So, and there's two benefits of that. First, they have the choice. The second is the different model has a pro and a con. So they may be able actually to know what's behind that, to really understand what's the specific advantage for the specific model. And the second thing that we learn from that, besides the foundation model we know well right now, and for the scientific area, and they have what we call the domain foundation model. It is a foundation model. It's not application, and it's complicated enough, and it needs the scientific data, and which is much more than text data. So scientific challenge needs something, some innovation that beyond the language model they have. So I would very much like call it a domain model. And above that, then I think it's good to build a lot of tools to really help the scientists, focus on their research, but we make the tool much easier for them. So I'm glad actually this architecture just works, and at the same time, governance is very important. Particularly, you're working on some really new technology. There's a lot of concern about the safety and ethical issue and IP issue. So I'm really glad actually we have a very good GeoGPT governance committee. If you view a GeoGPT an application, actually I'm not sure that's the only application around in the world have such governance committee. Okay, so we are very, very serious about how make sure it works for scientists, let's make sure it's good for the human being. Okay, and I'm glad actually most of the members actually are here for this event, and I really thank you for all the work they're doing for this for the GeoGPT. Okay, and again, it turned out it's a very good practice of open science. And Mike and other people actually wrote an article for geoscientists last year and talking about the GeoGPT, and we view it's a practice of the open science, and we want to make sure it's a good practice of the open science. And so when you have something new technology, it really helps us thinking about how this technology should develop and how this technology could help other people, and how we can have a good governance structure to make sure it's doing something good. Okay, and I'm glad actually with my experience with the GeoGPT, we really actually explore all these things for the other area of the research. Okay, and so putting a big framework is really about the AI plus science. Okay, and more important, today, the AI is becoming as fundamental as a math. So for me, the AI is another kind of math. That basically means it's going to help all the areas you can think about, all the different speciality of the science and technology. So then we very much focus on the three things. The first, we are trying to build what we call the large science model. The code name is 0 to 1. And it's different from large language model because it is very much, it needs the text and the language model, but it also needs scientific data, which is not the text. Okay. And also we need an infrastructure, just like this previous said, we need an infrastructure so people could share all these results. Okay. And so we do have the website called 02x.org, that make sure people could share these capability over the internet. And finally, we're thinking about we probably, with all the advanced technology, we can do much more than we can thinking about on the Earth. Okay, so we initiated an global initiative called the three-body computing constellation. So what's the background for this initiative? So thinking about the space give us a lot of imagination. So in the late 80s, it's about the same time when Turing wrote his first sentence about a human with pen and paper is a universal machine. And Sir Fred, and from UK, he actually envisioned, if we can take a photo of the Earth in the space. Again, at that time, there's no satellites, there's no space station, and nobody knows what the Earth looks like. Okay, but this vision brings us to understand the Earth. Okay, so for the space exploration, it's much more space. It actually helps understand our Earth. Okay, and this two photographs is very famous. Okay, and actually took by an astronomy of Apollo 17, the Bill Anders. Okay, and I really like what he said. Okay, we came to discover the moon, but we actually discovered the Earth. Okay, and so with such a photo, it helps us to understand the Earth a lot. Okay, so all the challenge we have today, we need to understand the Earth. Okay, but computing and AI might be a good way. And actually, in the history, they happen at the same time. So actually, Apollo 11 is the spacecraft actually first put the computing in the space. Okay, so they have this guidance computers. Okay, and with more than 1,600 transistors. Thinking about it, 3 years later, the first Intel CPU only has, over 2,000 transistors. So the chip technology, particularly the integrated circuit IT technology, was first actually used in the space instead of on the Earth. Okay, so space technology not just an application of our existing technology, but give us a good space for us to exploring the new technology. I think today we have this opportunity to explore technology, but also we have a challenge, just like geo-distributed. Okay, so we have a lot of challenge that we need to solve globally: the climate, nature disaster, like land degradation. But what Geo's vision actually tells us that actually through the Earth observation, we can better understanding our planet and help to solve the problem. Okay, so I really like the vision about the Earth intelligence. And when I first talked to them, I basically said, okay, it's Earth intelligence is a good application when we're talking about artificial intelligence. Okay, and certainly, this global challenge needs a global collaboration. And it really needs in-orbit, excuse me, in-orbit aggregation and processing of multi-source data. Then we're thinking about whether we could do all the processing, instead of bringing the data back from satellites down to Earth, whether we could do all the processing in the space. Okay. Then come with this basic idea, whether we could bring the AI into the space. And certainly, AI in the space needs something I would call the space computing. So I've been working on cloud computing for a long time, and finally realized actually all the cloud computing we're talking about is actually on the ground. Okay, and this is the first time we really put the computing in the space. So this actually redefined a lot of things. The first, today we want to have 3 kinds of satellites: communication, navigation, and observation. And now we probably could have the 4th type of satellites, what I call the computing satellites, okay? And certainly we want to make sure that we can collaboratively build that system, okay? And that's why I named it as the 3-body computing constellation. Probably most of you know this from a science fiction novel, and Netflix has actually shown a program for that. But actually, 3-body is a word from Isaac Newton. Okay, it basically means actually when you have 2 objects in space, it's easy to get an analytical solution and tells what's the relationship between them. But you have the 3rd object, now it's hard to have an analytical solution for that. So basically means collaboration is hard. Okay. But we want to make sure, even though it's hard, but we want to do that. So I'm glad actually South China Morning Post actually wrote an article about what we want to do. And again, I want to make sure instead of having a single organization or a single company to accomplish that, we want to make sure we have hundreds, even thousands organizations could work together and build this constellation. And so our goal is very simple. We're going to have the single satellites, and you can get together and do a lot of things. And this is the one example, how this could help the scientific research, okay? So thinking about, if we really want to observation some of the astronomy phenomena, and you want to make sure you can have a different sensor to monitor that, but they have to coordinate. So what the observation of gamma ray burst is make sure you have a sensor on different satellites, and these satellites are talking to each other, and when they detect and burst, and they send to the trigger satellites, and they talk to the other thing, and do all the computation in the space. This is the only way for you to observe the phenomena like this, okay? So at that time, so computing and AI is not just to make it better, but it's a must, okay? Otherwise, you can't make the observation like that. And even more is, our Earth is very much influenced by the sun. So we are working with some scientists that they're going to have the satellites set to for the sun. They call the sun satellites, okay? And the interesting is this satellite is going to be launched to what we call the Lagrange number 5, okay? So this point is very special. It has a distance from the Earth is around 150,000 kilometers. And so there's no way you send data back, okay? The only way is you provide the space computing for this satellites to do all the processing in the space, okay? And again, the L5 point is the place the human never send an object to that. So it's very exciting. It's a computing and AI could do a lot of incredible things. So finally, I want to say that computing and AI is our traveling companion for humans' journey to the Mars. As without computing AI, I don't think we're able to get to the Mars. Okay. Thank you for your attention. Thank you.